Welcome to the video description on AI-powered demand management system. I am Chatushka and my team members are Pabasara, Akila, Piddara and Shalita, and our supervisor is Dr. Subodh Charles. In recent past, Sri Lanka faced an energy crisis due to the lack of energy generation to meet the uprising energy demand. Here you can see the energy demand increasing in future. Our approach to address this problem is demand management. Let's see what is demand management. Demand management is controlling the electricity demand in a cost-effective manner. Through demand management, we can reduce the need for expensive new power generation facilities and respond better to changing conditions on the grid and can improve the power grid's reliability. Our project ADMS is a holistic approach to demand management, which aims of increasing energy efficiency of households and renewable energy penetration, which consists of smart devices, AI-based inference engines, and software platform for the user to interact with. This is the main component diagram, which consists of AC controller and smart plug as the smart devices to control and monitor power of the connected appliances. And learning-based models, which consist of future energy consumption prediction and future solar power generation prediction, and oversight monitor, web dashboard and mobile application for the user to interact with. Here's the system architecture. We are using Azure Cloud Services to host AI models and the backend application. For demand management, we need to control and monitor power. For that, we have developed smart devices. First, we have smart AC controller, which have developed to control air conditioner loads, which have the capability of remotely controlling power, temperature, and fan speed, and these other extra features. Here is the PCB design of the AC controller. Here is a demo video of how our AC controller is working. Next, we have oversight smart plug, which can control the appliances which are connected to the device, and we can real-time power monitor using this smart plug, and also we can keep power schedules and timers. We have developed this gateway device to connect the above-mentioned smart devices to the cloud. Using the gateway device, we can reduce network bandwidth utilization and can store power data in case of connection failures.
Now look at how AI models are used in our AI-powered demand management system. This is a detailed diagram of how AI models work in our ADMS. To manage a demand, we need to know future demand and future energy generation. We have developed two AI models for demand forecasting and generation forecast. Using the gathered energy consumption data from smart devices and natural factors like weather data, our model can forecast next 24 hours demand. Also, if you have solar PV in your rooftop, our model can forecast next day energy generation using weather data and historical generation data from your solar PV. We also developed an algorithm that can perform optimal scheduling using the output of demand forecasting and generation forecasting AI models. let's look at how demand forecasting model works. So we initially trained this model using individual household electrical power consumption dataset from UCR machine learning repository. We collected weather data from Soulcast data API. This is the performance of our AI demand for forecasting model. This model can forecast next 24 hours demand with 1 hour frequency, and the root mean square error to this model is 0.09 kilohertz. Now look at our solar energy generation forecasting model. We trained this model using the solar energy generation dataset from the Open Energy Data Institute repository. We collected historical data from the Soulcast data API. Now look at the performance of this generation forecasting model. This model can forecast next 12 hours energy generation with 1 hour frequency, and the root mean square error of this model is 0.5 kilohertz.
Demand management algorithm is the combination of previously explained topics. Let's look at how it developed. And this diagram shows how the smart devices, readings that gathered from the smart devices and the predictions that calculated from the AI inference engine to use to develop the demand management algorithm. And let's look at how it works. Assume there is a scenario where the grid has more power demand than the supply, and then utility provider needs to limit the power demand. So utility provider can give a input to the demand management module with requesting automated power demand management, and demand management module will calculate the most suitable power cutoff plan, and and demand management module will decide what are the devices that need to cut off. Okay, let's look at what are the features that we are using to develop the demand management algorithm. First one is predicted power demand that gathered from the AI model and the consumer type, and the consumer can select a priority, and utility provider can also select a priority, and also the history of the power cutoff. And then user interfaces. These are the control panel of our system. So there are main two user interfaces in our system. First one is mobile application, which can be used to have a communication with the smart devices and control of smart devices. And second one is web dashboard. Web dashboard can be used to have a detailed control of the system and proper analysis about our system. This can be used to both the consumers and the utility providers. Next, let's look at how our deployment works. So we deployed the system into the AltaVision office, and we gathered data from those AC controller and the smart plug. So with using those data, we created the data set over a certain time. For a monthly period, you can see this data set, and this is all about our system, AI powered demand management system. Thank you.